welcome to everybody who is joining us. I'm really excited for this session to hear some tech predictions, which may or may not come true. Thank you so much for joining me. I'm Christina Criddle, and I would like you both just to introduce yourselves briefly and to tell us just a couple of things that you're really excited about coming in the next few years. We'll start with you.
Okay, I'm Young Sohn. I am chairman of Samsung Semiconductor and also chairman of HARMAN, which you might know as a JBL, the sound systems. And I think what I am really excited about is how the technology can be able to really moving at non-exponential way to make an even bigger impact. And I'm hoping we can all be able to get the benefit of that in terms of power, performance, but also being able to provide more sustainable way of supporting what we need.
Thank you.
Yeah, good morning, everyone. My name is Lars Reger. I'm the CTO of NXP Semiconductors, so Eindhoven headquartered, the former Philips Semiconductors. And that Philips Semiconductors married 8 years ago the former Motorola Semiconductors. And in that match, we are building all sorts of electronics for smart connected devices, or as some of us nerds would say, for smart robots. Now, for me, of course, the most exciting thing is that we are changing from the on-demand world, Young needs a pizza, presses a button, Lars needs an Uber, presses a button, into the world that anticipates and automates. And the analysts love that because they forecasted in the next 10 years there will be 70 billion of these smart connected little robots. And if I have the silicon ingredients to sense, think, connect, act, and make these devices trustworthy, then I'm sort of unavoidable in the market, and that's of course a nice pitch for the stock markets, and then that is the exciting story from my side.
Great news for you.
Absolutely, yeah, I hope so. Yeah.
Just to pick on that, I mean, the ingredients are really a vital part of this. As we've seen with scaling AI, this is core to scaling. And how can companies do that efficiently? How can they get the resources and also keep up with compute needs, the costs? How do you manage all of these things? Lars, I'll go to you first.
So first and foremost, I mean, when I believe my own echo, and the 70 billion smart connected devices come to life, we have a huge problem, because if we would use them on today's technology, these devices would consume 3 times the energy of this planet. So in other words, not doable. If not, we find ways to have smarter power concepts. And this is not only of cooling of high compute units for large language models. The cooling is a second order thing, but avoiding the energy consumption. The other part is, it does not help me if I take every idea, pump it to the cloud, get an intellectually high-flying answer back from an LLM into my devices. I mean, biology, we are built in a way like having this intelligence, this AI at the edge. And this AI at the edge is maybe one of the most driving slogans for us to make sure that you have smaller AI systems where you need them. In your hearing aid, in your insulin pump. They have to be highly functional safe, so really reliable. You don't want your insulin pump to do crazy stuff, but you also don't want your fridge at home to buy 500 liters of milk for the weekend. I mean, that thing is off the grid, you go shopping yourself again. And if your car does funny things, you drive your kids to school in a tank, if these cars are out there on the roads. So we really need to make sure that it's not only AI and that we don't overhype it, but in principle it is back to robot building, and safe and secure AI at the edge is a totally unresearched field. Good news is it's very close to the European core markets, and it's a lot of employment for you guys, for me, and for my kids. So I have high hopes that this is one of the leading segments in Europe. So.
Young, again, I mean, there is the hype. You might think we don't need to be hyped, but there is the hype. There is this competition for resources. These costs are insane, and they're only going to get more insane. How can businesses navigate that?
Yeah, so I think every technology wave, right? There is, if you think about mobile, the cloud, now the AI, I think there's always an excitement. And the reason NVIDIA became most valuable company today is because typically in the beginning of the wave, It's the infrastructure that you need, so you can keep up with the demand of AI. So that's really, I think, what's going on. But the issue of a infrastructure today is we are using 30-year-old architecture that came out of really the server architecture that need to keep up with the new AI space. So it's not very power efficient. It moves a lot of inefficient data, and also it's very power hungry and very expensive. So I think we need to have a lot of innovation. And the reason I believe deep tech is very critical, for you, deep tech has a lot of meanings, right? What is deep? It's not shallow. I think we talked about 70 billion devices getting connected. Well, powering all those things in concurrently with intelligence, with the security, all that does not happen automatically. You need the technology to enable it. And that's what deep tech is about. And I think right now is era of deep tech because these are the companies that are giving you the tools to do what you need to do. But eventually it's an application that's going to drive it, just like we've seen in mobile era, just like we have seen in cloud era. So we are in that transition. And in deep tech, I think we have a tremendous opportunities to make it lower power, to make it cheaper, and to make it safer, more secure, and more intelligent. And I think that's the journey that we are in, and we can talk more about that.
Yeah, and I think that's what's really interesting about this is the environmental concerns are only just starting to come to the fore now. I mean, do you think that there's a sense that when we look back on this period, we might regret how we've been advancing AI?
Yeah, I think there is, even I worry about the kind of power density we are at. If you look at number of power stations that we need, yesterday I was at McKinsey. They were presenting in Munich conference, talking about their projection of number of the power plant we need to support the kind of AI that we need. And basically, we are going to need 10% more incrementally next 5 years to enable the kind of a power we need for data centers. How can you increase power by 10%? It's easier for tech guy to project a 10% improvement in performance, 10% more in memory capacity, 10% faster bandwidth, but 10% more power, that's difficult to do. So I think we are going to be inherent in balance with power need versus power gets available. So I believe there are many discussions about even nuclear coming back and others. So there is a lot of other way of trying to solve this problem. I think that's going to be continuing to be a challenge. But the opportunity is we can reduce power. And I think we can reduce power through a better architecture. Because as you know, most of the power is because it's not about compute. It's the movement of data. So actual compute itself, it only requires 0.1 picojoule. I don't know when is the last time you guys hear about picojoule, okay? 0.1 picojoule, just remember that. And when you move that data from compute to your HBM module. You guys heard of HBM module. This is a memory where you're moving to, so you can move the data back and forth. That HBM stack is already 10 picojoule. So that means from compute to the first memory stack, it requires 100 times of power. These are the movements of data that we're used to in traditional compute, but I think we have to solve that issue. We need to make it much more efficient. For instance, if you have to go from building 34th floor to another 34th floor, instead of going to next door, you have to go elevator all the way down to somewhere, and then taking elevator back all the way to 34th floor to knock your neighbor's door. It's like this.
Lars, you strike me as an optimist.
Yeah, and I think you asked whether we are regretting things.
Whether we might in future.
So I think yes, and we are already in the middle of it. So I was at Computex 2 weeks ago, and I tried to exactly tell that story. So transform myself to the 80-year-old Lars in 2050, and then tell my granddaughter what we have screwed up on the way to smart robotics. One thing that struck me already in the last 8 years was in 2016, all the big newspapers were writing 2020 is the year of the autonomous vehicle. A quarter of the vehicle market, they forecast in 2016, would be in 2020 already fully autonomously driving. The same newspapers. 4 years later, were like, the techies didn't get it into place. It's all wrong. The smart car does not come that quickly, and so on. So what had happened in between? People in 2016, for the first time, understood how mighty AI can be, and then they were assuming, okay, just throw AI into the car, and everything is good. No one of you wants to be driven by ChatGPT. I can tell you, it's a great tool. But I mean, you cannot afford a funny mistake every 2-3 minutes. Therefore, we had, again, this old story. We had to re-architect how the robot brains are built. And you are talking here, or you're listening to a biological robot. I have a real-time system with reflexes. When I stumble, my spine says already, Lars, straighten your leg. Who needs to know what I'm stumbling over? Straighten that leg, otherwise you're face down on the ground. Then I have a system, my cerebellum, that keeps my heartbeat, my stomach under control, my temperature control, my blood pressure, while I am sitting here. And only on top of that, there is a cerebrum that desperately thinks, what is the next sentence, Lars, that you are saying to this entire crowd here in the room? So this is decoupled architectures. And in 2016, we thought it's all a main brain on wheels.
But Lars, same time, if you think about car today, did get benefit of a lot of R&D that went in to make autonomous driving. And although it did not happen, I don't think it's going to happen very near term, but I think most cars that are coming out today have this ADAS capability. Assistant
fully agree. So we are getting there. We are getting to these brain architectures. And I mean, of course, we had to move. But that was Christina's question to what would we regret? We had maybe typical hype cycle. Been too optimistic in the beginning, then frustrated, then come to the real architectures. And now you see, so I'm just coming out of Stuttgart yesterday evening, big automotive conference. Pony AI is announcing that they have already a fleet of 1,000 cars level 4 autonomous driving with these newer reworked brain architectures. And nothing would have happened without AI, but also nothing would have happened without safety, security, and rethinking this architecture from a robot side. It is. Sorry.
It's really interesting, and this sense of a new architecture. I mean, I think the focus so far has just been on scaling bigger and bigger and bigger, but maybe that's not necessarily the right approach.
No, you're absolutely right. It's a brute force approach. And you know, most of the application today is about training. And I think Lars mentioned about intelligence is at the edge. And the edge is really like your mobile phone that you're using. That's the edge device. So, I mean, I don't want to advertise Samsung phone, but, you know.
So you're going to do it anyway.
So I'm going to do it anyhow. Like, if you look at like the latest S24, right? It has probably 5 AI applications with AI processor already built in. This is a great example of edge device. You don't have to send your data to cloud. You can locally process. And I can take a picture of my shoes and find out what it is without even going to cloud, and to see the kind of search functions you can create, collaboration with Google. These kind of things are happening, so it will reduce power, and it will be more importantly, your data stays with you, rather than it's going all the way to cloud where they know everything you're thinking, what discussion you're having, which I think is concerning as well. So security, privacy, and efficiency power are very critical parts of, I believe, where we are going. But right now, I think there's a lot of training going on. But I believe edge is where the opportunity is.
Absolutely.
Which I think where your company is working on as well.
Yeah, so that is our big hope for money. But I mean, Young, very good point, is it is also not at the edge that we are free of large language models and so on. I see the first attempts now of the researchers saying, okay, I have a self-driving car, and how do I give the trust to Lars in the passenger cabin that this car is not doing totally crazy things? So get me a large language model, or a medium-sized language model at least, into the car, and read to Lars what I am seeing. And the car says, Lars, I'm driving now here a narrow cobblestone road in Amsterdam, and by the way, I just see a ball rolling onto the street, and now I'm doing an emergency brake, and my restraint system comes on. This is how the car builds trust to me, and shows me exactly what it is thinking and how I can interact even and can say to the model, do an emergency brake, next time you see a ball, better react in a different way. So these systems take all of these technologies and even get better by learning, but as Young said, it is always the end use in mind from where you re-architect your robot and then pull all these deep techs in to enable the use.
So if I can just add a bit more on the large language model and the training in generative AI, which is great in many ways to give you ways to communicate and share. But when you're looking at specific applications, when you're looking at patients care, when you're doing driving, or when you're doing specific, let's say, analysis of your data in your enterprises, you really cannot go out and solicit information from web and then combine with that, try and figure out what's going on. And this is where you are going to have a very targeted, very embedded, enterprise-grade, and I think data that goes in have to be very compact. And then through that, you can solve a particular problem. So specialized language model, I think, is coming, and this is kind of next generation of, generative AI will be there, of course, but I think you will see enterprises cannot afford to use hallucinations, irresponsible data source, without knowing where it's coming from. You have to be able to trace it. For safety, you have to know where it's come from. And I think all those things are going to help us and drive a separation and segmentation and specialization of models.
And do you feel like consumers and the users of these products are fully alive to some of the energy concerns, but some of the privacy concerns as well? Or do you think that they're just like, oh, this is fun, I'm just going to try it out? Lars?
Psychologically, we always make a mistake as human beings. We overestimate the next 2 years, and we totally underestimate the next 10 years. So the car example, yeah? Hey, in 4 years, everyone will be self-driving. Nonsense. Hey, 10 years later, there is level 3, level 4 driving cars on the road, to stay in that example. So also here again, I'm talking to my parents, and they are always my main test pilots for my stories. My mom just got 89 last week and was a primary school teacher. And she's, of course, like, Lars, I don't want to have these crazy things in my house and then the espionage devices and so on, until I get them to experience what it can bring to them. I mean, and you know that all. I mean, 30 years ago, dating in the internet, scary. In 20 years from now, maybe, hey, let's compare our DNA profiles first, whether our kids might have inherited diseases or not. So, I mean, that is, at the moment, it's a wild thought, and you are laughing. Let's talk in 30 years again, where we are. So these type of things take their time. You will experience it, and it will not happen over a fortnight. But this is a longer process. And believe me, we will have our nasty experiences with crypto security, what Young mentioned earlier. We might even need to pedal back because there might be AI against security, and we might need to use AI to protect us again. Same on functional safety. So that is definitely not a thing over half a year, but we are getting there. A 10-year horizon will be very promising.
I think that analogy is really interesting because, as you say, like it's quite an alarming example. I think it might turn some people off. I mean, how much do we know that people want these things? Maybe self-driving cars, do people want them? Do they want AGI? Do they want this dating scenario that you've laid out? And does that really matter if they want it? It's going to happen anyway?
So look, I give you one example. I mean, people are sitting there and say, I don't want to have AI because AI is taking my job. And I'm always saying, look at the airline pilots 1950. They had been great pilots, and they were all flying these postal airplanes, Junkers U-52, these old-style German airplanes, and it was pilots with these arms and flying through thunderstorms and heroes. Today we have more pilots. These pilots are sitting in an Airbus A380, 800 tons of weight, on the Frankfurt or Amsterdam Schiphol runway. And what is the pilot doing at the end of the runway on his way to San Francisco? 30 seconds, pulling back the handle when the machine has the right speed. All the rest is autonomous. There is more pilots, there is bigger crews, but the pilots of 1950 cannot do that job. You need to be trained very differently, so the higher level jobs will be fun for all of us, but we will be much more equipment observers. We will be much more in caring jobs where the human component is unavoidable.
I think
jobs
we are in the stage where it's not like we have a choice. It's like if you think about internet, right? Back then, internet is that for some people that want to communicate. I'm talking about early 1990s. Internet is for some router companies. Internet is just for IT companies. But actually, if you think about today, you don't think about it. It's just part of how we communicate, part we share information, and this is how we are. I think AI is embedded in everywhere we do. So it's there. I think that I agree with your comment about are we in hype cycle? Every new stage of innovation, there is that hype that enables certain excitement and also certain overinvestment. Right now, there's overinvestment going on. Why? Because this is how you get the momentum going. And there's always optimism about some prediction about where it could go. But I think it's more vision rather than reality. And Silicon Valley is very good at portraying what's possible. Why? Because this is how they get their funding. And then they want to get the momentum going. But although I think it is a bit too early, but I do believe there's a benefit of investment cycle. There's a benefit is actually it does make the transition of technology transition much faster than otherwise could happen. I know at Samsung, for instance, we're looking at how many fabs you need. Fab is a manufacturing plant for chips. And to support the AI journey, I think we need to figure out collectively as an industry $400 billion of fabs that are needed next 6 years.
Yes.
And that's a lot of money. Can you make money? Well, we think so, but I think it's going to be the kind of discussion we're going to have, right? We put that much money in. Before the market is there, it's one of those bets. And in tech, we take a bet. We take a motion around what we believe is coming.
And I think, I'm glad you mentioned Silicon Valley, and Lars, you indicated this earlier. I wonder whether you think we're at a bit of an inflection point in terms of where the power is concentrated around the world, and whether there's a chance that other regions can challenge the US, China, in this new age.
Okay, so I have some benefit of living in Silicon Valley, working with companies around the world, and particularly also the largest memory company, Samsung. So I have some perspective on this. I think some of the technology companies are very hard to touch. The scale and the size. And so I know in many ways, semiconductor industry has been one of the most globally efficient industry, right? You design somewhere, you fab it in Taiwan, you put memory from Korea, you put in the modules, you test it in Malaysia, and then it goes into Europe, it goes into US. That has been the model that worked. As you know, about 5 years ago, the geopolitical tension is real, and the people are worried about, first of all, pandemic forced us to think about supply chain rigidity and the flexibility, but also the value system, whether we can be able to count on the supply chain, a very critical part. For instance, 80% of all the leading edge logic chips coming from Taiwan today. So if that stops, there will be no iPhones for you, for instance, right? Because that's where the chips are coming from, or cars. 80% of all the memory chips come from Korea, Samsung and Hynix. So those two countries, for instance, has huge, let's say, optimization of globalization, but yet we're all dependent on it. The modern society would stop if something happens over there. And it's not always a very peaceful area, right? There's a lot of tension. The war in Korea never ended, right? It's a DMZ, which means that temporarily stop, not the permanent stop. So things like that we have to mindful. So we have to think about global supply chain, redundancy, and this is what I think is in. This is why also, along with the tech wave, there is a lot more sensitivity about how this tech can impact all of our lives, and we have to manage with the right policies.
Lars.
Yeah, so in Europe, there is 24 million jobs directly depending on semiconductors. And what Young had just described, if these supply chains get a disruption, we have a huge problem. Therefore, these technology sovereignty discussions in politics, I mean, there is a good reason why suddenly someone is interested in semiconductors, yeah? The political ecosystem was scared 10 years ago on these complicated global things that Young and Lars are talking about. Today, we are strategically important as an industry simply due to these massive impacts. The semiconductor industry is expected, maybe it's wrong, but it's expected to double in the next 8 years. And that is largely due to the 70 billion smart connected devices and all the big data centers that do large language models and so on. So the demand is ultra high. The supply chains are global, but they have local singularities. And we need to resolve these local singularities. And I think we have a good chance to do that. But what we need for that, at least this is how I talk to the politicians, is saying, give me a research roadmap for Europe or for the US, give me a development roadmap, and please not an R&D roadmap and everything in one pot. Yeah? Research, for example, quantum computers, development, microcontroller architectures, and give me a manufacturing roadmap. And for all of that, we need to have talent. It is a lot of money and it is a lot of work. But if we don't do that, well, we are falling behind. I mean, these things are not coming for free. And in the Silicon Valley, there is one of the focal points where a lot of this entrepreneurial spirit is. But we have a lot of assets also here on the continent, machine building, robot building, security, all of these type of things where we can move the needle. Yeah?
I'll give you one funny story. During pandemic, I got this phone call from a German CEO, which I'm not going to tell you who that is, very major company. Said, Young Sohn, you are Samsung. I cannot get a part. Can you help me? And I said, yeah, you know, not all chips are created equal. It's not like potato chips. It requires different technologies. So you're using technology from like generation ago, like, you know, and we have moved on. You need to move your technology in touch with the latest technology. And I think the funny thing is how people didn't think of that as critical part of their supply chain until the whole pandemic hit. And so I think post that, people are really much more aware of the importance of chips. Remember, chip industry takes about 5 to 8 years of planning ahead of its time, because the manufacturing plant takes 3 years to put together. The latest fab is about $25 to $30 billion per plant. And Lars mentioned about the talent pool. You cannot just hire specialized people overnight, so it requires training. So deep tech is about long term. Deep tech takes patience. Deep tech requires industry and government collaboration. Only when you do that, you can be able to manage your deep tech journey. Otherwise, we're all consumers.
And looking at the long term, I mean, you say we're very focused on the short term here. So in 10 years, if we were doing this panel, what would be the key thing that we were talking about? Will it still be AI, Young?
Absolutely. But I think AI, not just about infrastructure. I think infrastructure will be given. Things are going to be much lower power. I'm getting optimistic. I think it'll be much faster. And I think it's more about how exciting, what kind of app you're doing, how it's helping us. And maybe it's going to help us to build and find better drugs that are particular to your body types and your demographics. That type of accuracy using data, we get much better insights around our lives, and therefore maybe we can be able to be living much better world.
Lars?
I think we will talk about AI in a way that it is a part of our daily life. You will not ask me in 10 years anymore whether there is cars driving autonomously on the highway or whatsoever, these type of things. There will be a lot of our jobs. I mean, I was just half a year ago in the most modern TSMC fab in Taiwan, and these jobs in these factories are the following. In the past, in semiconductors, we had always these clean room, burqa type of dresses, no particles, run in there, work there. In these modern fabs, it's only maintenance workers, and the rest is automated. And the real operators of the factory are sitting in a type Cape Canaveral mission control center, 3 screens, some in the US, some in Taiwan. So a lot of our jobs will be of that kind. So this Airbus operators and not crazy pilots anymore. So a lot of that stuff has lost its scariness is part of our daily life. And potentially in 10 years, you're going to ask me, Lars, when now really is the first quantum computer using the AI algorithms? When is that in serious production? And who of you can already use quantum computers for the next startup ideas? Yeah, I guess this is in 10 years. And
People have been
2050,
asking for those for a long time, I think. Thank you.
It's always 10 years.
Wow, I could chat to you guys for ages. Thank you so much for your time and your insights and your predictions. Thank you to the audience for listening.
Thank you.
Thank you.